Hello and welcome. In section 2.4 we'll look at some Venn diagrams with three sets. And verification of equality of sets. So we'll start by sort of building up one subset at a time. So if our universal set has only one subset, we basically just have two regions inside the subset and outside the subset. We saw last time if our universal set has two subsets, that Venn would draw the overlapping circles. Euler would sort of examine the sets first, and we have four distinct regions. So region 1 would be in A only, region 2 would be in the intersection of A and B, region 3 is B only, and region 4 inside the universal set but outside of both A and B. So if we have three distinct subsets, we basically just add one more ring to the drawing. I'll make my rectangle a little bit taller this time. So here's our subset A, subset B as before, overlapping. A little imagination, we can pretend that I can draw freehand circles that are equal in size. And then we have C overlapping down here. They're not always necessarily named A, B, and C. As you saw last time, A and B might be P and Q or R and L. We could have different names for the subsets. And once again, our number of regions has doubled. We went from 2 regions to 4 regions. Now this one we have 8 distinct regions. 1 is still A only, 2 is A and B only, 3 is B only, 4 would be A and C only, and 5 is the overlap of all 3 regions, all 3 subsets. Region 6, we have B and C but not A. Region 7, we have C but not A or B. And region 8, inside of our universal set but outside of our other regions. Let me have us work on shading different regions. So this is more just a continuation of what we've done in previous sections. So let me make a blank one, and then we'll do different shading exercises. So here's our universal set. We'll have 3 subsets. Subset A, subset B, and subset C. And there's our 8 regions. In red here, I will shade, let's start with A intersect B intersect C. So this is saying it has to be part of all 3 pieces. The only region that's part of all 3 is region 5. Region 5 only has all of the pieces. However, if instead, and I'll do this one in blue, if I'm asked to shade A intersection B, not only do I have region 2, but that will also cover region 5. So this one was 5 only. This one covered both 2 and 5. So A intersection B, notice it does not stop at the top part here. This part that's been shaded both blue and red is still part of circle A, it's still inside of A, it's still inside of B, it would still be part of that intersection. So see if you can identify the regions and shade. Let's see, we'll have you try B. We'll try A union B, A union B union C, and the complement of A union B union C. So see if you can solve those four, shade them, and identify the regions. Okay, welcome back. So hopefully you paused it and tried it out. If not, go ahead and pause it. We'll make a fresh Venn diagram for this problem. So remember our regions, 1 is A only, 2 is A and B only, 3 is B only, and so on. So regions 1 through 8. So B not only is region 3, if it just says B, it's everything inside of B. So it's regions 2, 3, 5, and 6. So we'll do, I'll put a little key on the side of it. So region 2, region 3, region 5, and region 6 all are inside of circle B. So similarly for the second one, and I'll just do the same but in blue, A union B, anything that's inside of circle A or in circle B. Remember the union, if it's in one or the other or both, we get to keep it. So I get to keep all of region 1, all of region 2, all of region 4 and 5, as well as everything over here. So we kept regions 1, 2, 3, 4, 5, and 6. So 1 through 6, all of it would be A union B. If we're also including C, then I guess I'll go to black crosshatch, A or B or C. Now we have everything that's anywhere in any of the circles. Quiz or a test, you would want to split these drawings up a little bit more. I just want to squeeze everything onto the page for the moment. So this would be region 1 through region 7. So then the complement would be everything except region 1 through 7. So that one, I'll just do dots for that. That would be region 8. So region 8 only for the complement of A or B or C. So the next thing we do is we look at, well, what happens if we start putting some elements in here? So for this next one, our universal set, we'll go with 1, 2, 3, 4, and we'll go through stopping at 10. Set A we'll do in roster notation. That will contain 2, 3, 5, and 7. Set B, we'll go with, we'll do a little practice in set builder for that guy. Set all x such that x is in n. Now notice I'm saying x is in the natural numbers. We couldn't have 11 in set B though. Remember, our universal set says this is all we're looking at for the given problem. So natural numbers, here it's implied that the natural numbers are between 1 and 10 inclusive. And x is even. And C be the set of all x such that x is in the set of natural numbers. And again, we have this restriction based on the universal set for the problem that our universal set only goes through 10. So natural numbers for this problem, we're only concerned with the ones that go through 10. And let's see, what did I pick for that one? X is less than 5. So we're going to place these in a Venn diagram and then use it to answer a few questions. So we'll just start there. Place in a Venn diagram. So here's our universal set, as always represented by a rectangle. 3 sets. I tend to draw my rectangles a little bit taller. And here's our 3 overlapping subsets. A, B, and C on the bottom. So when we're filling these out, generally we want to try to work our way from as far into the middle as possible and work our way out from there. So in other words, we tend to try to start in region 5 if we can. So I'm trying to find anything that fits all 3 of these requirements. So it's one of either 2, 3, 5, or 7. It's an even, goodbye to 3, 5, and 7. And it's less than 5, so that's our 2. 2 met all 3 of these descriptors. 2 is part of all 3 sets, so the 2 will go in region 5. So then we work our way into the rest of the overlap. So in A intersection B, the overlap of A and B, I want everything that's in both A and B that I haven't written down so far. So 2 is already used up. Sort of check him off. B says that we're looking at even numbers. A didn't have any more even numbers to share. So region 2 is actually empty. It won't have any elements. A doesn't have any more evens to share with set B. So then we'll move on to region 4. So that's the intersection of A and C. So these guys, except for the 2 that we've already placed, together with any of them that are smaller than 5. So that would be the 3. If we had less than or equal to 5, we could also drop the 5 into section 4. We had strict inequality though. So the 2 is placed, the 3 is placed. So now we'll move on to region 6. So region 6 is B and C. So numbers in our universal set that have both of these properties. So we want something that's an even number that's smaller than 5. Well, we already have the 2, but 4 is also an even number and it is also smaller than 5. So we've done all of the overlap on these. So now we'll move out again, and now we'll look at the sections that only hit one of the 3 subsets at a time. So for example, with A, we've already placed 2 and 3, but 5 and 7 didn't fit into either of these other categories. That means they're going to go into region 1. B, X is in our universal set is a natural number and even. We already have 2 and 4. However, we have not put down 6 or 8 or 10 yet. Those are other even numbers. So those would have to be part of B. So C only, less than 5. We already have 2, 3, and 4, but we haven't listed our friend the 1 yet. So here is region 3 here for the B only crowd, and region 7, the C only crowd. And then region 8, any number in our universal set that we haven't yet put down. So we have a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8. I don't see a 9 yet. 9 will be outside then. And we do have the 10. So all 10 of our elements are in there somewhere. Sometimes you will have an empty region. That does happen from time to time. Sometimes you'll have multiple elements in one region. That happens too. So let's see if you can put this to work. So see if you can find and list these in roster notation. We'll try B intersection C. We'll try A intersection C. We'll try elements of C and the complement of A union B union C. So see if you can form these 4 sets. Again, write them in roster notation. Go ahead and pause it. Unpause it when you're done. Welcome back. So B intersection C. Here is, I'll just kind of highlight here. Here's B. Here is C. So the intersection will be the overlap of those 2 circles, and I don't care about this other cut in between them. A is not part of this at the moment. I'm pretending that only circles B and C exist. So this set contains 2 and 4. Even numbers that are smaller than 5. A intersection C, part of the list 2, 3, 5, 7 that are also less than 5. So that is our 2 and 3. So that is regions 4 and 5. The overlap of circle A with circle C. C. Set of all x such that x is in set of natural numbers and less than 5, or just within our circle of C. You can see we have elements 1, 2, 3, and 4. The complement of the union of all 3 sets. The union of all 3 sets is everything inside of the circle, so the complement would be anything outside. In this case, that was just the 9. So next we look at equality of sets. So for this one, our universal set will contain P, Q, R, S, and T. Set A will contain P and Q. Set B will contain elements R, S, as well as T. So the first question is A complement union B equal to A complement intersection B. Well, this one we'll do it just by roster notation, since this is a very small universal set we're working with, only 5 elements. So we'll find A complement. So A complement everything in the universal set except for elements of A. So that would be R, S, and T. So A complement union B would be anything in this set, anything in this set, or anything that is contained in both of them. Looks like we don't have any P's or Q's, but they both have an R. We'll list the R. Remember, we only write it one time. We never write the same element twice in roster notation. They each have an S. We'll put an S in there. They each have a T. We'll put a T in there. And there is our union. So to see if it's the same as A complement intersection B, again, we'll just examine those two in roster form, and we want this time only things that are listed in both. So R is listed both times. S is listed both times, so we get to keep it. T is listed both times, we get to keep that. So are these equal? In this case, yes. You might have noticed that I put a little bit of emphasis on saying in this case. So next we want to know, okay, is this true in general? To see if this is true in general, we go with the Venn diagrams. So here's our universal set. Subset A, subset B, and a little reminder on the regions, 1, 2, 3, and 4. So we're looking to see if these two are equal to one another, so we will need an A complement. So see if you can figure out what regions are covered by A complement. Hopefully you saw regions 3 and 4 are in A complement. So B contains 2 and 3. So A complement, we did the union first. A complement, union B. Union, if it's in one or the other or both, we get to keep it. So because of the B, we get to keep region 2. They both have a 3 to contribute. We'll hang on to that. A complement, we got to keep region 4. So 2, 3, and 4 would be in A complement union B. I'll sketch that in with little red stripes. 2, 3, and 4. Now let's check out the intersection. Remember, intersection, it has to be in both. If it's not in both, we don't get to keep it. So what's the only thing we get to keep from these two lists? What's the only thing they share? They share region 3 only. I'll do that one in blue. We can see I didn't shade the same thing both times. So is this true in general? That is a big fat no, not true in general. Different regions. So that was, we had a special case. We had something that works sometimes. So I'm going to have you all try to, and let's see, our first one is A union B quantity complement equal to A complement intersection B complement, and then we'll flip them. All right, so go ahead and make your sketch, pause it, and see if you think these are true or false. Okay, welcome back. So here's our universal set. We're only talking about 2 at the moment, so I'll just draw the 4-region Venn diagram. So A union B is region 1, 2, and 3. So then the complement would be only region 4. A complement, things that are not in set A. I do need the labels of A and B in there. A complement would be everything outside of circle A, so 3 and 4. B complement, everything not in circle B, so that's 1 and 4. So A complement, intersection B complement, things that they both have in common. This had a 3, this guy didn't, this guy had a 1, this guy didn't, but they both had a 4. So this one I'll shade region 4 only, and this time I shaded the same thing both times. This one is true in general. This one is a yes. Make one more sketch here, region A, region B, and our overlap. Okay, so A intersection B is region 2 only, the overlap. So the complement of A intersection B is everything but region 2, so that would be region 1, region 3, and region 4. Do that one in red, so 1, 3, and 4. So everything but the little middle football there. A complement and B complement, the same regions that we had in the previous problem. So we'll jump right to the union this time of A complement with B complement. So the union, if it's in one or the other or both, we get to keep it. So because of B complement, we get to keep region 1. Because of A complement, we get to keep region 3. And both of them have a region 4 to bring to the table. And notice this is also regions 1, 3, and 4, exactly the same. So this one is also a yes. These are what's referred to as De Morgan's laws. We're going to see them again later in our logic section as well. All right, so some problems I recommend trying out. This was section 2.4. Let's see, 1 to 3 all, 5 through 19 on the odds, and 33 to 69 also on the odds. I'll also try to remember to upload a generic MyMathLab for the MyMathLab fans. If you have any questions, please get in touch. Otherwise, stay safe out there, and I'll see you for the next video.